Today we're going to be explaining about hyperbolas. We can see a general equation of a hyperbola, opening left and right, being x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Notice the similarity between an ellipse, which instead of the subtraction sign we change to an addition sign. We can see that the hyperbola has a center point, which is modeled by this general function as center point hk, as visualized within the graph also. Several key points about hyperbolas are that they have two vertexes, the first vertex being right here and the second vertex being right here. Well, the first vertex, which I'm going to be doing as point A, will have the coordinate of h plus a, k, with the second vertex, point B, having the coordinate of h minus a, k, which we can find out by the definitions of the a value within this general function, which is the distance between the center point to its first vertex, or its two vertexes respectively, which this will be a, and this will also be a. Therefore, having this general function, or general point for the vertexes of a hyperbola. Next up, after the vertex, we also have the hyperbola's focus points, which, as we know, because a hyperbola is a conic section. Therefore, we have points C and D labeled as such, with point C being the first focus point as h plus ck, and the second one being h minus ck. And this C right here is different than this C, as the C that I'm adding to h for the two focus points are actually their focal distances, represented by the variable c as well. So the focal distance for a hyperbola represented by c, this c just stands for the center, not its focal distance, but here the focal distance for a hyperbola will be the square root of a squared plus b squared, the same a squared and b squared underneath x minus h squared and y minus k squared. And there we have the focus points for a hyperbola. Then we could define the b value right here within the hyperbola. The b value will look right here, will be the length of these segments right here, this red line and this red line. And with those definitions, we can find a hyperbola's asymptotes, which will have two, looking something like this, passing through the hyperbola's center point, in this case hk. So there we have the two asymptotes, where the hyperbolas will infinitely get closer to these two asymptotes but will never reach. So the functions for these asymptotes will be y minus k is equal to the positive negative b over a multiply parentheses x minus h. And there you have the equation of the two asymptotes for a hyperbola. And then, after this, we have concluded the entire hyperbola system, excluding its eccentricity and its directrix, which, as a brief preview, will have a directrix between its center and vertex. And there will be two, as such, right here in these black lines that I've just drew, and also its eccentricity being greater than 1. And there we have concluded all of the information from a hyperbola with x minus h squared over a squared minus y minus k squared over b squared is equal to 1.